let's say we have a function y equals f of t that tells us how many miles we've driven from home after t hours. Okay, so this f of t tells us how many miles we've driven from home in t hours. So what does f of 2 mean? All right, so 2 is the input, and the input is t, which is time, and the units here are hours, right? So the 2 is in hours, and the output of this function is in miles. It tells you how far we've driven, right? So this is miles. So if we want to interpret f of 2, what that means is just that after 2 hours, we've driven 120 miles from home. Okay, so let me write that out. We've driven 120 miles from home. Okay, so home is sort of like our origin, and we've gone 120 miles from home in some direction, right? Okay, in the positive direction. So we just have to define what positive means. But, okay, the next question is asking us to interpret f prime of 2 equals 70. Now, we've done these things before. Again, the input is still t. It's in hours. And the output is the derivative, right? So it's a rate of change. And when the rate of change of displacement is velocity, right? The units here are going to be the units of the function, miles, and then per hour, right? Because now it's the derivative. So we take the units of the original function divided by the units of the time. All right, well, that kind of clears things up. That 70 is a 70 miles per hour, so it's basically telling us our velocity. So if we want to interpret this, we would say at 2 hours, right? 2 hours since we started our journey from home. At 2 hours, it's giving us our velocity. So I'll just say our velocity is 70 miles per hour. Okay, so it's telling us how fast we're going. All right, now this next question wants us to estimate f at 2.5. All right, so again, this is still t, this is still time, this is still the number of hours we've driven. So we want to figure out basically how far are we from home after 2.5 hours. If we know that after 2 hours we were 120 miles from home and we were traveling at 70 miles per hour. Okay, so I think that even without calculus, you would think, okay, well, if 70 miles per hour, that's 35 miles and a half an hour. So let's just add 35 miles onto 120, and we can figure out where we are. I think you could do that without calculus. But essentially what we're doing, we're finding f at 2.5, right? And we're taking the distance we were at 2 hours, right, which was 120 miles. We were 120 miles from home at 2 hours. And then what we're doing is we're adding on 70 miles per hour times the additional half hour, right? We went for another half an hour. So we're basically taking 2.5 minus 2, taking the time difference, and multiplying by the 70 miles per hour, right? So this is just a half an hour. So if we travel 70 miles in 1 hour, then we would travel 35 miles in a half an hour. So you end up with 120 plus 35, and we get 155 miles. Okay, that would be our estimate, right? Now that's assuming, the big assumption here is that we're traveling at a constant velocity, right? It's assuming that we're not going to speed up or slow down, right? Now this could be wrong, right? This could be wrong because in that half an hour period, we maybe have to slow down for, might have to, oops, we might have to slow down for, you know, road construction or something like that. So it's not, but it's probably a decent estimate, right? If we want to know where we're going to be in 2.5 hours, how far from home, we just use the rate we're going right now and project forward. So now what that is a linear approximation, because you're assuming a constant rate of change, right? You're assuming that we continue to travel at 70 miles per hour over that next hour, right? Constant rate of change, right? That's constant. That's the slope, right? The rate of change is the slope. So essentially, it's the slope. So we're using a linear approximation. We're assuming that our function is linear, and we're projecting forward. And sometimes a linear approximation is good. Sometimes it's not so accurate, but it's a decent approximation given what we know. So let's got one more question here. Interpret your answer in part C. Okay, so now all we need to do is just like part B. We're going to say after 2.5 hours, we could say, yeah, we've driven 155 miles from home. Okay, that's our interpretation of f of 2.5. All right. So the point with this is that we're using the derivative, right? We're using the derivative to project forward to approximate values beyond what we know, right? We know our position at after 2 hours, and we know our velocity after 2 hours, and we're using the derivative to estimate where we'll be at a different time, right? Now we could also use it to estimate where we were in the past, right? So this is called linear approximation, and that's what we're going to talk about today.